Okay, let's give this another go. Let's check out the Great Gate Machine. Let's get down here, through here. Hopefully he's gonna keep missing me. So that's where we're going. Still gonna fill that upper empty area with gates or something, with little fences to not leave a hole. So this is the main thing here. We're gonna open it first, and opening it is pretty straightforward, as you'll see. That's what happens. What was that? I have no idea. So let's close it, and I'll just watch from up here, hoping that nothing goes wrong. Let's just watch. Let's get that out of the way. It's gonna happen a few times. Takes a while. It used to be faster, but I had to make it slower to avoid a few conflicts. If the clock is too fast, the server can't handle a few updates. So I just changed the 5 clock to a 7 clock instead. I'll show you the clock later. But yeah, we'll just sit here for a while. You can kinda hear a lot of pistons downstairs. There's a lot of work going on. And we'll go down there shortly and check it out. Alright, we'll just wait for that to close. There it is. Gate is closed. So now I'm going to open it again. Now we're going to close it and go see what's happening downstairs. So let's see the inside of the machine. So this is where everything falls, and you can see the blocks being moved. They move down here and up here. Let's go further down. This is the system of pistons, elevators. These columns are the blocks are transferred from each of the columns and then pushed into this elevator, which is then pushed into a second elevator. And then you saw what happened up there. So there's quite a bit going on here to get the blocks to move from one to the next. These are individual controls for each one of the elevators. This is a machine, a sequencer, that pretty much tells all of those elevators what to do. It's controlling all of that. Let's go down there. These are just wires bringing the commands all the way up to the gate. Fucking creeper. That's okay. Signals going up. The elevator. Not the elevator. The sequencer. Sequencer's still running. Let's go around. So, I don't think you can hear anything. Which one of these redstones here? It's loud. It's gonna stop now. So yeah, each one of these redstone torches here is one channel, it's one command. So just stop clock, close slot, which is the side slot where the blocks in the elevator up there comes from. Open slot are the same. You can see like a little yellow block here. Push wall, which happens 5 times for each side. Elevator 2 and 1, and then the little transfer circuits for transferring the blocks from one column to the next. From 5 to 4, 4 to 3, 3 to 2, 2 to 1, and then elevator 1 transfers from 1 and pushes it up. Elevator 2 pushes it up further. And then push wall pushes it inside. And what this does here is just sequences the commands in time. A transparent block here means no command in the channel, and an opaque block means a command in the channel. So for example, this channel here for stop clock stops the clock. So that's what this guy does. The black block here, when it got pushed in this position by this piston, stop the clock. And when we run the machine, first command that you get is open slot. The last one is push wall. Well, the last one is stop clock, but before that, sorry, you get close slot and then stop clock. You should see a close slot here somewhere. There it is. See those there? Those are the push commands. This here are safety circuit breakers, which kill the signal to each one of those, from each one of those lines there, for safety reasons. When I want to test the machine without actually causing anything to happen, which I'm gonna do now to demonstrate. and I can also kill the signal from each one of them individually. This is the clock generator, which gets killed by this piston here, controlled by this latch here. So I'm going to start the clock by activating this button, which flips the latch. This can stop the clock. I'm going to start it. Clock is flipping here, causing pulses to get sent. Causes this. Take a step back here so that you can hear me. So that is just a big ribbon-like structure. It's a big loop. Blocks that gets just looped around. Kind of like a Turing machine, but not. It's just a loop of blocks that get pushed and send commands. Kind of like a recorded tape. Not like a long punch card. And you can see the commands being pushed here. Which cause the signals to come here. You have some signals that go up there, the signals for the sides of the wall, for like push wall and open slot, and one of the elevators, elevator 2, goes directly up there. The rest of them come through here, because they need to go to the bottom here, to those there. You're not going to see anything flashing here because we used the circuit breaker. And those send the signal up. Let's go back up for now. We can see them. Yeah, see those. This is the second layer of circuits from the pistons. This is the bottom layer of where the wall falls. And the pistons for the transfer engines, if you will. As you can see here, I have a second set of circuit breakers. If I want the signals to come up here, but not get to these transfer engines or motors or pistons, so I can also kill them here. And it's also closer to them if something's going on or going wrong, and if I just want to kill everything from here. And just like up there, I can kill them individually. Let me re-enable this guy, since the engine is done running. Cup. Okay, so this, I should have shown you this before. This is the small scale prototype for the big machine, the big sequencer over there. So this makes it a lot easier to understand what's going on. So it's pretty much the same thing, but small. And you can see here that it's just a loop of blocks that get pushed up here and to the left, and then there down and to the right sequentially. So it keeps going in a loop. And these pistons here, when the blocks get here, push these blocks down to this spot, closing this circuit here or not, depending on if the block is solid or transparent. If the block is transparent, they do not close this circuit. If they're solid, they do. So the result is, if the block is solid, this signal carries, and if the block is transparent, the signal does not carry. That's it really. So with this we can just program a sequence of pulses in that machine. And with this I was just testing the concept for the machine, and then here testing a way for separating the signal, because as you can see we have the problem of having two lanes very close to each other. I could build them further apart, but then the machine would be too big, and I wanted it to be compact. So by having them like this with alternating repeaters and redstone, and then taking one of them down, I could easily split the lanes, which is how it's done down there. So let's turn this on. Same 5 clock, even though like that's what I was using down there. Now it's a 7 clock, but it's the same thing. As you can see, when it closes the circuit with a solid block, the redstones light up. When it's a transparent block, they don't. That's it. You can see the pistons just alternating. First this and then that. Same here. Turn this off because it's loud. So yeah, this pulse, it's the same thing that happens there. One pulse just triggers the whole thing based on delays. So there's a higher delay for this, a lower delay for that. And then this guy's trigger the pistons that push it down. It's just timing based. And this is a loop, while the bigger one is kind of an accordion layout, but still a loop, just a bigger loop. As you can see, like it winds like that. See, like the top is the same shape because these blocks, a piston can only push so many blocks, and this is, I think, the limit. And then we have to just wind down. And then it goes like this, just winds and winds and winds. And I think based on my calculations for the amount of pistons and the number of blocks that I would need to power and control the pistons, this is the optimal, or at least the best that I could come up with at the time when I designed this. Then just powering the machine itself and the pistons was a whole other puzzle. There's Excel spreadsheets for just the design and the number of commands that I needed, and for the commands themselves, and then making the layouts, how many little turns I would need, and to get the number of commands that I would require for sequencing everything. And then these little curves with the repeaters also had a sheet, and it was not Excel, by the way. Excel sucks. It's Google Sheets, which also sucks, but it's not Microsoft, so that's something. But yeah, that's the prototype and the real thing. But yeah, this seems to be working fairly well now. No gaps. I was having gaps before, but those were just timing issues with some of the pistons. As I said, the server tends to be very sensitive to timing. You need to leave a couple ticks of just a couple extra ticks for just error, margin of error, because the server is not as consistent as when you're running locally. At least when running on Realms, which is what I'm doing now. Yeah, that's the Great Wall Machine.